Hello students, welcome back to my YouTube channel. Today we will discuss about the next topic, that is atmospheric pressure. So let's start with this topic and finish it. And by this topic we'll finish today the theory part. The theory part will be over today. Tomorrow there will be two more lectures, lecture number 9 and lecture number 10, and within the next two lectures I will solve the few numericals and also will discuss the few theoretical reasoning type of questions which generally happens to come in the exam from this chapter. Okay, so let's discuss today's topic, and today's lecture number 8. So in all the previous lectures we have learned what? If we talk about pressure, solids exert pressure. Similarly, liquids also happen to exert pressure. Now let's talk about gases. Does gases exert pressure? Does gases or air? Gases means air. Air is a mixture of all the gases. Does air exerts any kind of pressure? Let's think. Air has a mass? Yes, air has mass. Because we have learned in our previous classes, class 6 or class 7, that air is a matter. Air is a matter, and if air is a matter, of course it will have mass. Any body which has mass, does it has weight? Yes, it has a certain kind of a weight also. And a body which has weight will exert a thrust equal to its own weight. We have learned that. And any body which exerts a thrust on a unit area, on a particular area, will definitely give pressure. So think, air has mass. A body which has mass will exert a kind of a weight, and if a body exerts weight, it will give thrust. Thrust means what? Force. It will give force, and that force or that thrust will be equal to its weight. And the thrust, if it also gives thrust, then obviously it will give pressure. So air exerts pressure. And if air exerts pressure, let's talk about this thing. This is our earth. This is the surface of earth. And we know the surface of earth is covered by what? Is covered by atmosphere. So say this is the atmosphere. Say this is the atmosphere. This atmosphere has a certain kind of mass. Because of that mass, it will exert a weight in the downward direction. Because of this weight, there will be a thrust. And if this thrust is applied on a unit area, on a particular area, say this much of area, okay, then on this area, on this green area, there will be what? There will be pressure. So this pressure, which is actually applied by whom? This pressure is applied by the atmosphere. So this pressure is applied by whom? By the atmosphere. And the pressure which is applied by the atmosphere is called atmospheric pressure. So the pressure applied by atmosphere is called atmospheric pressure. So if we talk in good words, like nice words, so thrust, acting. Thrust means what? Force. Thrust, acting means exerting. Thrust, exerting or acting on a unit area. On a unit area is called atmospheric pressure. Now let's talk about the most important thing over here. Thrust, you understood. Thrust means what? Force. Acting on a unit area. What this thing unit area means? Unit area is called atmospheric pressure. So let's discuss and let's clear the concept about unit area. So thrust means what? A force. A perpendicular force acting on a unit area is called atmospheric pressure. Let's understand this by an example. Our normal atmospheric pressure that we happen to get, the normal atmospheric pressure is about 10 to the power of 5, is near about, okay, near about 10 to the power of 5 Pascal. This is the atmospheric pressure. So atmospheric pressure is this much, 1 lakh pascals is 1 lakh pascals. So 1 lakh pascals means what? 1 lakh pascals means 1 lakh Newton per meter square. That is what it means. Atmospheric 1 lakh pascals means 1 lakh Newton per meter square, because we have learned pascals means Newton per meter square. Now what does this thing means? 1 lakh Newton of force on an area of 1 meter square. On an area of 1 meter square, you get a pressure of 1 lakh Newton. So see, I have a area means what? Length. Length is 1 meter, breadth is 1 meter. Length is 1 meter, breadth is 1 meter, and length is 1 meter, breadth is 1 meter. So the area becomes what? Length into breadth, length into breadth. So 1 meter into 1 meter, that will become what? 1 meter square. Okay, length into breadth is area. So 1 meter into 1 meter, 1 into 1 is 1, meter into meter is meter square. So area is 1 meter square. So on an area 1 meter square, if I take, how much the pressure acts on this 1 meter square? 1 lakh Pascal, 1 lakh Newton, 1 lakh Newton of force acts on an area of 1 meter square. So that is why I have taken what? Area as 1 meter square. And 1 is always said as what? Unit area. Unit means what? 1 unit area. So unit means 1 unit area means what? 1 meter square area. So on a area of 1 meter square, 1 lakh Newton of force acts. So that is why thrust acting on a unit area. So force acting on a unit area, force acting on 1 meter square. So force acting on 1 meter square is called atmospheric pressure, because we cannot take the whole area. Whole area of the earth is very big, very big. We will not consider the whole area. We will consider a particular area. And how much area will take? 1 meter square. You consider, earth is so big. You consider the whole surface. No, we will not consider the whole surface. On a particular area of 1 meter square, how much the force acts? 1 lakh. 1 lakh Newton of force acts on an area of 1 meter square. That is why 1 lakh Newton per meter square, and 1 lakh Newton per meter square is 1 lakh pascals. So that is what the definition of atmospheric pressure. In exam, if this question comes, what is atmospheric pressure? And if you happen to write this answer, the pressure exerted by atmosphere is called atmospheric pressure, you will get 0 for writing this answer. Wrong. Okay, that is a wrong answer. The pressure exerted by atmosphere is called atmospheric pressure. Although it is correct in that way, but the general definition is this one: thrust acting on a unit area by the atmosphere. Okay, by the atmosphere. Sorry, forgot to write. Thrust acting on a unit area by atmosphere is called atmospheric pressure. Thrust acting on a area of 1 meter square by atmosphere or by the column of air. Now, as I always say, if atmospheric pressure is there of 1 lakh Newton, okay, if atmospheric pressure is there of 1 lakh Newton 1 lakh Newton per meter square, this is a very big value or this is a very small value? This is a big value or a small value? Answer is what? This is very big value. This is a big value. This is a lot of force. 1 lakh Newton means lot of force. Okay. But despite of having that much of force, atmospheric pressure, our body, we don't experience that much. Are you experiencing 1 lakh Newton of force on your body? Huh? 1 lakh Newton, you understand, is like 3-4 big trucks on your body. Do you feel that kind of pressure? No. We do not feel this much of pressure on our body. This much of force or pressure on our body, we do not feel. Although we are experiencing the atmospheric pressure, we are experiencing the atmospheric pressure, but we do not feel it. We are feeling normal. Why? Because the bloods that goes inside our veins of our body, inside the nerves and veins, there is a lot of blood going. That blood also exerts a pressure on our body from inside. From inside, the blood exerts a pressure on our body, and from outside, atmospheric pressure comes. So from inside, blood pressure, from outside, atmospheric pressure. And this blood pressure, our blood pressure is slightly greater, is not very high, but a slightly greater than our atmospheric pressure. So the blood pressure of our body is slightly greater than the atmospheric pressure. Suppose I do not know the exact value. Suppose this is 1 lakh pascals. This might be 1 lakh 1100 pascals, something like that. Okay. So slightly greater, and because of that, the pressure from the inside happens to control or happens to equate with the pressure from the outside. So as a result, both the pressure, inside pressure and the outside pressure, blood pressure and the atmospheric pressure, they cancel each other, they neutralize each other, and because of that, we do not feel any kind of pressure. Our body does not feel any kind of pressure. Why? Despite of the fact that 1 lakh pascals of force 1 lakh pascals of pressure acting on our body, we do not feel that kind of pressure. The reason is that what? Because the blood pressure happens to be nearly equal or slightly greater than the atmospheric pressure. So the blood pressure neutralizes the atmospheric pressure, and that is why the resultant pressure is 0. So on our body, we do not feel any kind of a pressure. So this blood pressure makes the atmospheric pressure ineffective. Ineffective. Okay, you understood this concept? Now, because of this only, I'll just give one reason. Consider this is the surface of Earth. Okay, and consider this is the atmosphere. Consider this is the atmosphere. This green line is the atmosphere. Now consider Mount Everest. Where is Mount Everest? Somewhere over here. This is Mount Everest. Now, if I am on the top of Mount Everest, am I experiencing more atmospheric pressure or less atmospheric pressure? Think. If I am standing on the top of Mount Everest, okay, I'm putting a flag on the top of the Mount Everest. At that point, am I experiencing more atmospheric pressure or am I experiencing less atmospheric pressure? Think. At that point, I am experiencing less atmospheric pressure. How? See, if I am over here at the ground means at the normal plains, okay, like in our city, the whole atmosphere is acting on our body. But if I am on the top of the Mount Everest, a fraction of the atmosphere acts on our body. Not the whole atmosphere is acting on our body. A part of the atmosphere, a fraction of the atmosphere acting on our body. So as a result, as the atmosphere above us is less, so atmospheric pressure also becomes less. Over here, in the plains, in our city, the whole atmosphere is above us. So the whole atmosphere is above us. So atmospheric pressure also becomes more. In the mountains, less atmosphere, atmospheric pressure less. So over here, atmospheric pressure becomes less. So as a result, what happens? A person who is climbing in the Mount Everest, as he reaches the top of Mount Everest, less amount of atmospheric pressure acts on the body. But the blood pressure inside his body is same. That never changes. Inside our body, the blood pressure remains the same. But the atmospheric pressure acting on our body, that decreases. And because of these unequal pressures, blood pressure more, blood pressure becomes what? Blood pressure becomes, at this scenario, the blood pressure becomes more than the atmospheric pressure. So because of that, the person starts bleeding from his ears, nose, eyes, okay? Because the blood pressure is becomes so high, there is no one there, atmospheric pressure is not there to control it. So because the atmospheric pressure is gone, or say becomes less, the blood pressure becomes more and more. And the blood pressure becomes more means what? More means what? That remains same, but the atmospheric pressure which was over here, that decreases. So as a result, now blood pressure becomes more than the atmospheric pressure. Okay, and because of that, in blood pressure in our body, the person starts bleeding from the nose, eyes, mouth, like that. So this is what this is also a concept that is also given in your book. So I think you understood this part. Now after this, we have to prove that, yeah, in general, atmospheric pressure exists. Atmospheric pressure is there, but do we feel it? No, we are not feeling it. Because why? Blood pressure and atmospheric pressure happens to become equal to each other in opposite directions, so they cancel each other. So resultant pressure becomes zero. But still, I want to know, does really any kind of atmospheric pressure is there in our system, in our atmosphere? To understand that, I will take an example. I'll take a glass of water. A glass of water. This is a glass and completely filled with water. I take a cardboard and cover the glass. Okay, cover the glass with a cardboard and turn the glass upside down. So now the glass will look something like this. Now the glass will look something like this. Okay. Did you understood? The cardboard is down and the glass is on top. Now I make it upside down and I remove my hand. As I remove my hand, I expect that the cardboard will fall off. Because of this pressure of water, the cardboard will fall down. But in practical, when I do this thing, I see what? The cardboard is not falling. The cardboard is not falling. The cardboard is not falling because there is a pressure of atmosphere from the downward direction. So there is atmospheric pressure from the downward. Okay, so this is what? Atmospheric pressure. This atmospheric pressure which is acting in the upward direction, atmospheric pressure which is acting in the upward direction becomes equal to the downward pressure of the water. This is the downward pressure of the water. So this is the pressure due to water and this is the pressure due to atmosphere. Both of them become equal and they cancel each other. As a result, this cardboard is now feeling no pressure and the cardboard stays in its original position. The cardboard doesn't comes down, doesn't falls. So did you understood? The pressure of the water is trying to push the cardboard in the downward direction, but the pressure, atmospheric pressure, is trying to uh, keep the cardboard in its original position, because the atmospheric pressure acts in the upward direction, pressure of water in downward direction, so both of them cancel each other and the cardboard stays. So by this one example, I happen to understand that yes, atmospheric pressure do exist. Now there is one more experiment given in your book. Okay, I'm just explaining the experiments. After this, what you do? Go through your book, read the book, you will understand. You take a jar of you take a jar. You take a jar of water. You put some water in the jar. You put some water. Take some water and put in the jar. Now what you do? You heat the jar. You heat by a flame, by a candle or a flame. You heat. Now what will happen? The water will start boiling. As the water start boiling, what will form? Steam will form. Steam, water vapor, steam. That steam will be trying to come out. Now this steam which is formed will do what? Initially there is lot of air inside this in this vessel. I have filled the vessel with some part of water, not the whole part I filled with water. Half or less than half I filled with water, and I happen to heat that water. Now as the water gets heated, it starts boiling and steam will be formed. This steam starts to come out, but as it starts to come out, whatever air is there inside the bottle, that will be removed. First the air will come out. And then the steam will be coming out. So steam will be forcing all the air to escape from the vessel. So as all the air comes out, then all the air comes out, then finally this steam happens to come out. So first the air will come out, then the steam will come out. As I observe the steam is coming out, at that point I get to see the steam is coming out. At that point I stop my burner. I remove the flame. I remove this flame away, and as the steam is coming out, then what I do? I cork it up. Okay, I put a cork on the top of the bottle. I put a cork. So when I put the cork on the top of the bottle, as the steam was coming out, I understood that all the air which was there initially in the bottle have escaped, because now only the steam is coming out. At that point I remove the flame and cork it up. Now as a result, what is there inside? Inside the bottle, certain amount of water is there, and this whole area is actually what? Not air. This whole area is what? Steam. This whole area is filled with steam. Now what I do? I put some cold water. On this bottle. Now as I put some cold water on the bottle, first what will happen? All the steam which is there in this empty space, all the steam will do what? Will condense. I think all of you know the meaning of the word condense. Changing from the vapor state to the liquid state. Okay, clouds condenses to give you rain. So all the steam condenses back to water. So all the steam comes back in the form of water droplets, and it comes back to this level only. So all the steam condenses back to water. So right now what I have over here, I have what? Previously steam was there, but all the steam got condensed because I put cold water. So steam got back into water. Now think what is there in this empty space? What is there? Steam to not there, water is there on the bottom, all the air I have removed, all the air got removed, steam got condensed, bottom part water is there, but what is there over here at this point? What is there? There is nothing. There is nothing. And when there is nothing, I say what is there? There is vacuum. There is vacuum in this part of this bottle. Vacuum means what? No air, nothing. So at this point vacuum is there, and because the vacuum is there, what will happen? No air. It has no air. If there is no air, is there any kind of air pressure? If air is only not there, how can there be air pressure? Think. No air. It is vacuum. Because all the air got removed, steam got condensed. Okay. So this part is vacuum. So it has no air. If it has no air, it has what? No air pressure. So no air means what? No air pressure. If this part has no air pressure, then what will happen? Think what will happen. But outside, I'm removing this cold water. Outside, what will happen is that outside there is lot of pressure. Outside from this bottle, there is a lot of pressure. What is this pressure? From the outside, these are all atmospheric pressure. Atmospheric pressure from the outside acts on the bottle. And inside, what is that? Inside, no pressure. So see, think, outside, lot of air pressure, 1 lakh Newton of force is acting. Outside 1 lakh Newton of force is acting, and inside no pressure. So because of the outside pressure is so high, it will do what? It will just simply crush the bottle. So the bottle in the second stage will look like what? So all this, because of this atmospheric pressure, the bottle will simply crush. Okay, this will crush. So since the bottle got crushed, what can I say? Why the bottle got crushed? Because of atmospheric pressure. So this gives us enough evidence, enough proof. Yes, there is atmospheric pressure around us. So the previous experiment where the cardboard was not falling because of atmospheric pressure acting in the upward direction, and this experiment that the whole bottle got crushed because of the atmospheric pressure, these two experiments gives us enough evidence that yes, atmospheric pressure do exist. Now after this, I will just request you, after I complete the lecture, you please go through your book and go through these two activities of your book. You will understand in a more better way. Okay. Now after this, what I have, now our atmospheric pressure, the atmospheric pressure is how much in Pascal? I told you it was near about 1 lakh, but the exact value, if I have to say, 101300 pascals. 1013, okay, 1 lakh 1300 pascals. Now think, point is over here, 1 2 3 4 5. So 1.013 into 10 to the power of 5 pascals. Okay, so this is the exact value of atmospheric pressure, and 1 lakh, which I said 1 lakh, okay, this is the near about value. So this is the exact value, this is the near about value. Okay, so this is the exact value of atmospheric pressure in pascals. Okay, exact value. Now there is something which you do not need to know in details in class 8, but atmospheric pressure is also measured in something like this: 76 centimeter or 760 millimeter of mercury. Now what is this mercury, where mercury came, where is 760, where is 76 centimeter, that is there in class 9. Okay, atmospheric pressure acts on a U2 and a kind of a U-shaped tube because of the mercury rises and how much it rises, 70 centimeter. So these things are there in class 9, but right now just remember this value, how this value came, or how this whole line is written, that you no need to know in class 8. As of now you don't know, just know this value, 1.013 10 to the power 5 Pascal. That is the exact value of the atmospheric pressure, and this is the approximate value. This is the approximate value. Now after this, there are certain examples of atmospheric pressure. Let's start about the first thing. I taught you that in mountains, if you happen to go, your nose starts bleeding. Why? Because the atmospheric pressure in the higher altitude decreases and your body pressure remains the same. Because of the excess body pressure, the from nose starts bleeding for the mountaineers. This part I already explained just now. Next thing, have you ever seen a lizard? Now yes, obviously you must have seen a lizard. Now if you happen to see a lizard happens to walk on the wall. How a lizard walks on the wall, have you ever noticed? Because of their legs, their legs or their paws, they are like a suction kind of a paw. Okay, it's like a suction paw. So whenever they press their hand on the wall, what happens? As it presses all the air between that lizard paw and the wall, as it presses, all the air escapes. Okay, so as I press my hand on the wall, all the air between my hand and the wall escapes. So because of that, what is there right now? No air. If no air is there, no air pressure. So between the hand and the wall, there is no air and no air pressure. Okay, but outside, lot of air pressure. So because of this, the outside atmospheric pressure is so high, it holds the hand fixed in the wall. Did you understood? Inside means between the paws and the hand and the wall, there is no air pressure. Inside, no air pressure. Outside, lot of pressure. That outside lot of pressure holds the paws of the lizard firm on the wall. So this is the reason how lizards happen to walk on the wall, because of atmospheric pressure. Now this thing also, if you have seen, if I have a tin and inside the tin I have oil, inside the tin I have oil, and I need to pour the oil out of this tin. This is the tin, oil in tin. Now if I have to pour the oil outside the tin, what I will do? Firstly, I can make one hole over here. I can make one hole. But if I make one hole and try to tilt the tin, what will happen? Through this hole, will the oil come out? Through this one hole, if I make, will the oil come out? Think. You might be thinking that the oil will be coming out, but the answer is no, the oil won't come out with this one hole. Because as you tilt, because as the oil starts to come out, what is acting? Atmospheric pressure acts on this hole. So oil is trying to come out, but atmospheric pressure is acting on the other side. So as a result, the oil gets stopped from coming out. The oil gets halted from coming out. So oil starts coming out from that hole, but from the other side, from the outside, atmospheric pressure acts on the oil. Okay, oil starts coming out, atmospheric pressure acts on the other side, and at the hole, atmospheric pressure pushes the oil backward and the oil won't come out. To avoid this thing, what I will do is that, to avoid, I will make one more hole over here. So I'll make two holes. Now as I tilt the tin, what happens? Through one hole, atmospheric pressure acts. So atmospheric pressure acts on the one on the first hole. So what happens? This atmospheric pressure will pressurize all the oil to come out from the second hole. So I'll make two holes. So as I tilt it through one hole on the top hole, okay, how will I draw? If I happen to draw like this, if I make two holes, one hole over here, another hole over here, through the first hole, atmospheric pressure acts. And because of this atmospheric pressure, all the air will go inside and will push all the oil to come out. So atmospheric pressure will go inside and will pressurize all the oil to come out from the other hole. So you make two holes. Through one, atmospheric pressure acts, through the other hole, the oil comes out. Clear? Now this is one good example, and this happens to come in the exam. Okay, this thing happens to come in the exam in lot of ways. Most of you happen to drink or enjoy cold drinks. Who doesn't enjoy to have cold drinks during the hot summer? How you drink cold drinks? Most of us drink directly, but say on a easier way, many of us prefer to use a straw and drink the cold drinks, because that way we enjoy drinking the cold drinks. Now how we happen to drink the cold drinks through the straw will be understood today, and this actually happens due to atmospheric pressure. Now I'll draw something and try to understand, and pay very close attention, because these things will help you a lot in answering the questions in the exam. This is a glass, and this glass contains some drink. Okay, Coca-Cola, Mirinda, whatever you will prefer. And here is a straw. This is a straw. Okay, this is a straw, and the straw is going in somebody's mouth. Okay, this is somebody's. Okay, the straw is going in somebody's mouth. Now, firstly, what happens? This person happens to suck. When it sucks, firstly, what comes in his mouth? Initially in the straw, what is there? Initially in the straw, air is there. Inside the straw, what is there? Air is there. So as he sucks, all the air inside the straw goes inside the person's mouth. So initially as he sucks, all the air which is there inside the straw goes inside the person's mouth. So as all the air goes inside the person's mouth, okay, whatever air is there has gone inside the person's mouth. Now air is there in his person's mouth. What is there inside the straw? Think, what is there? All the air to gone. So what is there? There is nothing. So now the straw has nothing. When it has nothing, means what it has? Vacuum. It has nothing means what? It has vacuum. So right now in the straw, what is there? Vacuum is there. Vacuum means what? No air. Vacuum means no air. If vacuum has no air, that means what? No air pressure. Think, he sucked all the air inside his mouth. So now in the straw, what is there? Vacuum. Nothing is there, so it is vacuum. Vacuum means what? No air. And if it has no air, also it will be having no air pressure. So right now in the straw there is no air pressure, or in your book there is given what? Low air pressure. No air pressure or low. L-O-W, low air pressure. This part clear? But atmospheric pressure is there acting. So on the surface of the drink, what is acting? Atmospheric pressure is acting. So on the surface of the drink, atmospheric pressure is acting. So atmospheric pressure is acting on this surface of the drink, and this atmospheric pressure will force the drink to go inside the straw. Think, the atmospheric pressure which is acting on the surface of the liquid will force the liquid, or the drink will force the liquid to go inside the straw, and it will go inside, it will go upward, the drink will go upward, the drink will go upward, and the drink comes in your mouth. So now the drink is coming in your mouth. So what happens? I am just recollecting. First you sip it. As you sip it, all the air goes inside your lungs. So right now in the straw, what is there? No air. No air. No air means what? No air pressure. So in the straw, no air pressure. But atmospheric pressure is acting on the drink, and that atmospheric pressure which is acting on the drink will force, or pressure is the drink to come inside the liquid, to come inside the straw. You know why? Because always force or pressure goes from a high pressure to a low pressure. It always goes from a high pressure to a low pressure. So right now in the atmosphere, what is there? High pressure. This high pressure, and what was there in the inside the straw? Low pressure. So the high pressure will force the liquid to go inside the low pressure or no pressure. So from higher pressure to lower pressure. That is why this higher pressure will force the liquid to go inside the lower pressure area, and lower pressure area means what? Inside the straw. So the liquid will go inside the straw and it will enter the mouth, and we enjoy the drink. So this is the reason. Other things are also there. How you use this stopper, okay? Sorry, it's not stopper, to fill up your pen's ink, okay? So that is the same way. The syringe also works in the same way. As you pull the syringe backward, low air pressure is created. As you pull the syringe backward, initially low air pressure is created, and that low air pressure will, and because low air pressure, the liquid which is the higher pressure will go inside the syringe from higher to a lower pressure. Think, as I pull the syringe back, vacuum is created. Vacuum means lower pressure, and outside where the medicine is kept, that is a higher pressure. So from higher pressure it will go to a lower pressure. So higher pressure goes inside the lower pressure, means inside the syringe the medicine will go, and then we can push inside the patient. So this was the concept or air pressure. I hope these examples happen to, and these things will make you understand this chapter much clearer way. So by now the theory part of this chapter is completed. Other examples are also there, but it's similar to what I taught. But just go through whatever this thing. This is very important. This is very important. Once you understand this part, then the other parts also becomes easy, other examples. So I will just ask you to, after you go through this, please read your book. Please read your book. After this you will understand it. So by this we completed the theory part. Tomorrow 2 lectures will be there, and over there we will be completing 1 lecture is for the theoretical question answers, another lecture will be there for the numericals. So by these tomorrow 2 videos, I think our force and pressure, this chapter will be completed. So hopefully you like my hopefully you enjoy the video. If you enjoy it, please press the like button, and if you have any doubts, please ask in the comment section, and also please subscribe to my channel. That is the first thing that you do. Please subscribe to my channel. If you subscribe, then all the notification of the videos will be coming. So do that for me, and good night. Take care.